Alright, let's go ahead and get started on 2-3. This is a lot of postulates that you guys have to memorize, so please make sure you're studying. Alright, the first postulate, it says 2-point postulate. Through any 2 points, there are exactly 1 point. So what this means is, through any 2 points, so if they're giving us 2 points, here are my 2 points, there is going to be exactly 1 line. So again, here are my 2 points, and I'm going to have 1 line going through it. So this is my 2-point postulate. Okay, again, starting with the 2 points, and then coming out to a line. Looking at the next one, a line point postulate. It's a line contains at least 2 points. So now this one's kind of the opposite. So this is line point postulate. I'm starting with my line, and it's telling me my line will contain at least 2 points. I'm going to go ahead and draw it for you. I'm starting out with a line, and then they're telling me that line will have exactly, or at least 2 points. Okay, the least amount will have 2 points. Line intersection postulate. If 2 lines intersect, then their intersection is exactly 1 point. So think about it. I have 2 intersecting lines, and they're telling me where the lines intersect. That makes exactly 1 point. And they're talking about my intersecting point. Now the next postulate is 3-point postulate. It says through any 3 non-collinear points, there is exactly 1 plane. So non-collinear meaning not on the same line. So 3 non-collinear points. If I have 3 non-collinear points, it's telling me that it's on exactly 1 plane. So definitely study these. There is a difference between all of them. It's a little hard to identify, but with practice, you guys will get it. Please look at the drawings too. It definitely helps distinguishing through what it's starting at and where it's going. All right, we have 3 more postulates. This one is plane point postulate. So it's saying a plane contains at least 3 non-collinear points. So similar to the last one, but instead this one's talking about a plane. And they're saying the plane will contain at least 3 non-collinear points. So I'm going from a plane to my points. This is plane point postulate. Plane line postulate, if 2 points are in a plane. Okay, so let me just go ahead and draw that. Here's my plane. Here are my 2 points. If 2 points are in a plane, then the line that contains those points is in that plane. So it's showing me that this line is going to be in my plane. So plane line postulate. Plane intersection postulate says if 2 planes intersect. So drawing this as best as I can. So here are 2 planes. If 2 planes intersect, then their intersection is a line. And here is my intersection. This intersection is a line. Okay, so these have to do with planes. Perpendicular figures. So looking at the perpendicular figure, it says a line is perpendicular to a plane if and only if the line intersects the plane in a point and is perpendicular to every line in the plane that intersects at that point. So I know this sounds wordy, but we should know from prior knowledge that perpendicular is 90 degrees. It makes a 90-degree angle. And you will see perpendicular formed in geometry as the symbol, an upside down T. So looking at this, first thing I notice is that this says if and only if, which makes this statement biconditional. Biconditional, which means regardless of which way I say it, it's always going to be true. So this is basically saying that point T, since it is perpendicular, and how can I tell? Because of this little half square right here, this 90-degree mark, my right angle. Because this is a right angle to my plane, every line that goes in here will be perpendicular. Right, looking at this example, it says state the postulate illustrated by the diagram. So looking at the first one, it says if two intersecting lines, I'm interpreting the image, if two intersecting lines, if two lines are intersecting, then there is exactly 1 point. Okay, so looking at this one, going back to our postulates, we should be able to figure out that this is going to be my line intersection postulate. Okay, looking at the next one, this has to do with my planes. So if two planes intersect, then their intersection is a line. So I had a line intersection, now I have my plane intersection postulate. So again, with practice, you will definitely be able to see the difference between the postulates. So please make sure you're practicing those. Looking at example number 2, it says use the diagram to write examples of the plane point postulate and the plane line postulate. So we're going to go ahead and do this one, the plane point postulate and my plane line postulate. So looking at it, plane point postulate. Looking at my plane, I'm talking about the points. So I'm going to state it as plane P. Okay, I'm talking about plane P. Oops. Plane P contains points. Oops, my goodness, I can't spell today. Plane P contains points A, B, and C. They're points, so I'm separating them with commas, which are non-collinear. Okay, non-collinear. Okay, meaning they're not on the same line. So plane point postulate means my plane contains at least 3 non-collinear points. Looking at plane P right here, A, B, and C are non-collinear points. Now I'm going to go ahead and do plane line postulate. And plane line postulate, I'm still dealing with plane P. Plane P contains points A and B, and also line AB or line N. Okay, so this is plane line postulate. So plane P, this is plane P, contains both point A and point B, which is on a line. Okay, plane line postulate. Here's my plane, here's my line. It contains 2 points, which are on line N. So 2 collinear points, which is on line M. All right, looking at example number 3, it says which of the following statements cannot be assumed? Remember, in geometry, you cannot assume anything. If it's not given, you cannot assume it. So which ones can I not assume from the diagram? So let's go ahead and look at this. A, B, and F are collinear. Collinear, again, meaning on the same line. So here is my A, B, and F. Are they on the same line? Yes, they are. So that one is good. Looking at the next one, E, B, and D are collinear. Already off the bat, I can see that E is not on the same line as B and D. So this one is one of them that I cannot assume. Why can I not assume that it's, why can I assume the statement that it's incorrect? Is because they are not on a line. I can't see where they're on a line. So there's no line that they're on. They are not connected by a line. So not connected by a line. Okay, they're non-collinear. They're not on a line. So let's look at the next one. Line AB. So here's AB. Is perpendicular to plane S. So this in red is plane S. How can I tell if it's perpendicular? I can tell by this right angle right here, this right angle symbol, the little square that it's showing me. Let's go ahead and do the next one. So that one's good. CD, line CD is perpendicular to plane T. So looking at CD, I can't assume that it's perpendicular. Why can I not assume it's perpendicular? Because there is no right angle. There is no right angle mark. No right angle mark. And let's just go ahead and check the last one. It says line AF, so here's AF, intersects line BC at point B, and that is true. So here's my line AB, BC, and it's intersecting at this point, which is correct. All right, last example, example number 4 says name a pair of supplementary angles and a pair of vertical angles in the diagram. So looking at this, again, vocabulary, we should be studying this, we should know it. Supplementary angles are angles that equal 180. I'm adding two angles together to equal 180 degrees. And vertical angles are like your opposite angles. Okay, so looking at this, supplementary angles, and then I have my vertical angles. There are different answers that we can get, but I'm just going to name one pair. So supplementary angles, again, we know that means two angles added together to equal 180 degrees. So two angles added together to equal a straight line. So looking at this, I'm going to go ahead and name this angle right here. So this is angle P. Oh, you can't really see that. I'll change the color. Angle PWT. And angle TWQ. So those are supplementary angles. If they're added together, they equal 180. And my vertical angles could be, let me change this color. Vertical angles can be angle PWV and angle TWQ. So they're sharing the same vertex, but they're not sharing the same sides. That's vertical. Okay, sharing the vertex, but not sharing the same sides. So right here. All right, please make sure you guys study all 7 of these postulates. You will see them on the quiz and test, so please make sure you know the difference.